Good morning, everyone. Today is the session part of Data Analytics and Automation System. I'm Karthian, working as an assistant professor, the Department of Mechatronics. So we are going to discussing a very important topic on Hadoop scalability. By the end of this session, you should have a clear understanding of how Hadoop handles large-scale data and why it is designed the way it is. Let's get started. So before we dive into the internals, let's see the foundation. Hadoop is an open source framework that allows us to store and process massive data sets across the clusters of machines, not just one server, but potentially thousands of them working together. Now, scalability simply means the system's ability to handle a growing workload by adding resources. Think of it as like this. If your application is a highway scalability is your ability to add more lanes when traffic increases. So why does this matter? Because today's data is massive. So we are taking petabytes, supporting thousands of users simultaneously. Hadoop solves this in a cost-effective way, and that's exactly what we will explore. And the Hadoop architecture components. Hadoop powers come from three core components, and I want you to remember all three. The first is HDFS, that is the Hadoop distributed file system. This is your storage layer. And second is MapReduce. This is the processing engine that crunches your data. Third will be YARN, yet another resource negotiator which manages the resources across your cluster. The most important thing to note here is that each of these components scales independently. That's a key design philosophy. You don't have to scale everything together. If you need more storage, you scale HDFS. If you need more computing power, you scale the processing layer. This modularity is what makes Hadoop more powerful. The Hadoop's scalability features. When a file is stored in Hadoop, it's broken into blocks by default. Each block is 128 MB. These blocks are then distributed across multiple machines called data nodes. Now, to ensure reliability, each block is replicated 3 times by default. So, even if one machine crashes, your data is safe on two other machines. The name node doesn't store actual data, it stores the metadata, basically a directory of where all the blocks are stored. There is also something called rack awareness, where Hadoop intelligently places replicas across different physical server racks to optimize fault tolerance. The scalability trick here is simple. Want more storage? Just add more data nodes. That's it. No complex reconfiguration. Then the map scalability mechanism. Let's talk about Hadoop process data at scale through MapReduce. This works in two phases, the map phase and the reduce phase. The map phase takes the input data, splits into chunks, and processes each chunks into parallel across the nodes. The reduce phase then takes all those intermediate results, shuffles them, and aggregates them into the final output. What makes this scalable? The parallel processing. Instead of one machine doing the all work, hundreds or thousands of machines work simultaneously. There is also built-in fault tolerance. If a task fails on one node, it's automatically retired on another. You don't lose your work just because one machine goes down. This is critical in production environment where hardware failures are common. The yarn and resource management, the brain behind resource management. Let me explain its component. The resource manager, node manager, application master, and dynamic resource allocation. The resource manager is the global scheduler. It knows what resources are available across the entire cluster. The node manager runs on every individual machine and reports its resource availability to the resource manager. For each application that runs, there is an application master that negotiates resources for that specific job. Finally, a container is the actual unit of resource allocation, CPU and memory assigned to run a task. Yarn enables dynamic resource allocation, meaning resources are handed out based on the demand. Multiple jobs can share the cluster efficiently without stepping on each other. That's what enables Hadoop to serve many users concurrently. Then the horizontal and vertical scaling. This is one of the most important conceptual comparison in the distributed system. Horizontal versus vertical scaling. Vertical scaling means upgrading your existing hardware, getting a bigger, faster server. The problem is expensive. There's a physical limit to how big one machine can get, and it's a single point of failure. Horizontal scaling means adding more machines, spreading the load. This is cost effective because you can use commodity hardware, regular inexpensive server. It's also fault tolerant because there is no single machine that brings everything down. Hadoop is designed for the horizontal scaling. This is a fundamental architectural design. When Facebook or Yahoo needed to handle billions of records, they didn't buy a supercomputer. They added thousands of regular servers. That's the Hadoop way. Let's ground this in a real world context so you can see what is actually used. For Facebook, Twitter, LinkedIn, all use Hadoop based system for social media analytics to analyze your user engagement in real time. And in IoT platforms collect continuous streams from millions of smart devices. Hadoop handles that scale. E-commerce giants like Amazon and eBay use it for commercial customer behavior analysis and recommendation. And the mind map gives you a bird's eye view of everything we covered. The core components, key features, scaling approaches, and application use this as revision reference. And to the summary, to wrap up, Hadoop scales horizontally by design. HDFS handles distributed storage, and MapReduce enables parallel processing, and Yarn ensures efficient resource management. These three pillars work together to make Hadoop one of the most scalable data platform in existence. Thank you.